Well, hello, boys and girls. Today what we're going to get into is our chimneys and drafts. This is another important part in understanding the combustion process and figuring out issues with a oil-fired unit if you are having problems with them sooting up, rumbling, and just constantly having overall problems with them, with a lot of no remedy or rhyme or reason to stuff. One thing that I found in many of my years of doing HVAC is that simply looking at a chimney, its construction, and looking at the flue pipes itself and venting is usually overlooked. And what I mean by overlooked, it's just not really thought about. It's like, oh, maybe the flue pipe is actually a problem. So what we're going to do today is we're going to kind of get into, your chimneys, what to look for, and things like that. So we all know now is that air is needed to burn oil cleanly and efficiently. Okay, we must understand how to supply air to the burner and how to ensure that all the gases created in burning the fuel are vented to the outside. Okay, additionally, for non-condensing appliances, we must make sure the water vapor created during the combustion process is vented to the outside prior to condensing inside our flue pipes. Because we know that water, if it condenses inside the flue pipes, it can start to corrode it, right? So we want to make sure that that's not happening to begin with. So draft, what is it? Draft is a current of air in an enclosed area that is created by a difference in pressure. Okay, during the combustion process, your hot gases rise through the heating appliance to the flue pipe and then out the chimney. Okay, which when that happens, it's creating a negative pressure, or what we like to think of as suction, also known as negative draft at the bottom of the chimney. So the pressure difference is created because of a couple of different reasons. When the burner is off and the chimney is cold, the air inside the combustion area, heat exchanger, flue pipe, and chimney are all at atmospheric pressure, 14.7 psia. When the burner starts, the burner fan creates static pressure, and that pushes the air into the combustion area where it's combined with the fuel, therefore creating a fire. When the air and fuel burn, the temperature rises dramatically and the combustion gases expand to more than double their volume. So as that hot air combustion gases travel up the chimney, they create a pressure drop between them that sucks the combustion gases out of the heat exchanger. Okay, so the draft really is a combination. It's a total effect of a couple of different areas. Okay, well, one, it's the positive pressure from the burner fan. Okay, it's from the expansive pressure of the flame and the negative pressure of the hot gases escaping to the top of the chimney. Okay, one thing that we always kind of think about when we're thinking about draft is remember that cold air falls. Cold air is heavier, so it's going to sink to the bottom first. Warm air is going to rise. So in order for us to create that draft, we have to definitely change the temperature of our chimney, our flue pipe, in order to get that draft going. Oil burners need a steady draft in order to have proper operation. Okay, if we don't have any draft, you're going to have issues. You're going to have sooting. You're going to have rumbling. You're going to have problems. Overheated nozzles, burnt up electrodes, so on and so forth. All crazy stuff. Okay, insufficient or variable draft is obviously going to cause a whole bunch of problems. So as a mechanic install guy, whatever it is that you're going to do, you have to make sure that these units are operating at a good and efficient draft. Now, different manufacturers, different specifications. You have to follow whatever those manufacturer specifications are. You have to make sure that the chimney is constructed and sized correctly for that type of application. You can't just take a burner boiler and slap it into a home and call it a day. You have to look at stuff in order for this stuff to work properly. Otherwise, you're going to have problems. So chimney venting creates natural draft, right? So there are two types of natural draft that's created in a chimney, and that's your thermal and your torrential. Okay, thermal draft is created when the air in the chimney is hotter and therefore lighter, less dense, right, than the outside air. Torrential draft is caused by the suction created as wind rushes over the chimney's top, creating a negative pressure inside the chimney. Occasionally, wind will blow down the chimney, and that's going to cause a downdraft. Okay, the draft produced by a chimney is variable. It's never constant. Remember, with temperature and pressure in anything that's related to HVAC, the hotter it is outside, the different pressure it is outside. The colder it is outside, the different pressure there is outside. So that's why we say that our chimney draft is variable. It's going to change every single day. Not unless we have the same consistent temperature throughout the winter, which we all know doesn't happen. So it's variable. The temperature of the outside air, the temperature of the flue gas, the barometric pressure, the humidity in the air all affect draft. Okay, now think about that. It's never going to be the same. Okay, so which kind of makes it very interesting when it comes to setting up an oil-fired piece of equipment is that one day you can get it set up for, to maybe operate at 86% efficient, but in reality, maybe the next day down the road or a day or two down the road, because of the fact is that the flue gas temperature has changed, the barometric pressure has changed, the humidity in the air has changed. Now the operation of that furnace now changes. So when the burner is first fired, the chimney is going to be cold. It's going to be full of cold air, and therefore little or no thermal draft is going to be taking place. So as that chimney and gases warm up, the draft will then strengthen. Okay? As the outside air cools, the temperature difference increases, so therefore your draft is also going to increase. Other conditions that are going to affect your draft is wind velocity across or into the top of your chimney, your flow restrictions in the chimney, flue pipe, or heat exchanger are things that are also going to affect the way this guy drafts and removes those flue gases. It is important that the chimney be properly constructed, clean, and have no air leaks through cracks and gaps. Okay, a chimney operates best when it is warm and dry. The outside chimney heats up slowly and then it's going to cool rapidly, right? It's because it's going to be exposed to the outside air. Additionally, the chimney must extend at least 2 feet above nearby objects such as your roof peak, your trees, and other buildings within 10 feet. That is actually a code. That is something that is very, very important to know. So when you are looking at a chimney from the outside, it is probably really it's probably good practice to go and take a tape measure. Is the chimney above extending at least 2 feet above any nearby objects, such as the roof peak, trees, or other buildings within 10 feet? Is it there? If it isn't, there you go. You already found one clue to the puzzle there, Sherlock. You need to figure out the rest. Okay? Overhanging trees or high buildings can affect the draft and cause wind currents to tumble, causing a downdraft. Okay? Because remember, it's an obstruction. Improper or variable drafts can also cause a lot of your problems. Okay, variations in chimney drafts can change the amount of combustion air entering the burner. Your low draft will cause the burner fan to push against high air pressure, resulting in less air for combustion and therefore having a smoky fire. High draft will cause too much air to rush into the combustion zone, resulting in reduced efficiency. Excessive draft can also cause excess air to leak into the unit, also increasing your stack temperature and also reducing your efficiency. So here's an example of what we talked about with different variations based off of different temperatures. So here's case number 1. We have an outside air temperature of 60 degrees. So let's take an average here. Say we did an inspection or a service on a unit, and we had a average temperature, chimney temperature of 300 degrees. We went and we measured our chimney, and we found that the chimney is roughly 20 feet. So at that, we should have a theoretical chimney draft of somewhere around 0.09. Okay, that's at a 60-degree day. But what happens if we go maybe a week or two later and we had a temperature of 0 degrees outside? It got really cold. We look at the differences between our drafts here. It's 0 degrees outside. We still have an average temperature of about 300 degrees coming out of our chimney. We know that our chimney height is still about 20 feet. Look at what happened. It went up. It went from 0.09 to 0.12. Why is that? That's because of the change in temperature, change in humidity, the change in the air quality that we're dealing with from one day to the other. So chimney draft is going to change no matter what we do. What we got to do as a mechanic, HVAC guy, is we got to try to fine-tune these things to where we can get them at their highest efficiency with very little issues. It can actually be very difficult depending on the situation. Okay, effects on draft on your air leakage. So if you have an appliance that has a high draft, it's going to draw air into that appliance through all the leaks that it has. Okay, this air will cool the combustion products while increasing their volume, which is going to reduce the efficiency of the heating system. So it's really good practice to make sure that the system is sealed. Make sure that all the panels are on. Make sure all your gaskets are in place. Make sure your flue pipe is sealed and caulked and cemented the way it's supposed to be per manufacturer's specifications. Because remember, we only want to introduce the correct amount of air where we want the air to enter. And that's through the burner. We want the furnace to do the rest. Okay? Ensuring that the draft is proper, therefore using a draft regulator, which is going to be in our flue pipes, that's going to help improve the efficiency. Okay? Sealing all of your leaks with furnace cement or high temperature silicone whenever possible is going to reduce the amount of air drawn through the appliance. Okay? Air flowing up the chimney is replaced by air being drawn into the building through windows, doors, and other gaps in the building envelope. Okay? Which brings me to another point. Where do all the leaks come from? There's a lot of areas that leaks can come from, okay? But most of the common ones are going to be around your burner mounting flange. It's going to be around between your base and your floors, the base and the floor. It's going to come between the base and the heat exchanger, between the sections of a boiler, okay, around your clean out and inspection doors and plates. All of those areas should be sealed and put where they need to be. Okay, effects of draft on standby losses. Just simply when the furnace is just sitting there waiting for the next call for heat. So whenever the air inside the chimney is warmer than the outside, the chimney will create thermal draft. Okay, this is very important for the draft from the still warm chimney to draw warmed air from the building into the burner air intake and up through the heat exchanger. Okay, this new hot air keeps the chimney warm, which in turn keeps producing a draft that cools the building. The best analogy that I can think of that kind of describes what we have just talked about is, think about a fireplace. We have a fire burning in our fireplace. That fire goes out. That chimney is still warm from the heat that was just generated by that fire. Just because the fire is out doesn't necessarily mean that we are still not creating a draft and sucking air out of the home. We still are, simply due to the fact that we have a warm chimney. That temperature difference is going to create a thermal draft, which is why standard open fireplaces without a fireplace cover, they're very, very inefficient. They actually suck more heat out of the building than they actually heat the home. Okay, but that's what happens when we have a leaky appliance that has leaks all over the place. Even if that furnace is still sitting there waiting for the next call of heat, it's still warm. The chimney is still warm. I'm still creating a thermal draft. I'm sucking heat and air out of that home. So in regards to that, draft regulators, just like what we just mentioned, right? It is necessary to regulate the draft because natural draft is so variable. The most common draft regulators that we have are your bypass or your air bleed type. Okay, since it responds to changes in barometric pressure, better known as atmospheric pressure, it is also called a barometric draft regulator or damper. Okay, the regulator consists of a counter-weighted swinging door that opens to allow room air to flow into the flue and mix with your exhaust gases. The room air dilutes and cools the exhaust gases, which reduces the temperature difference between the gases leaving the chimney and the outside air, and therefore that's going to reduce the draft. When the draft drops below the regulator setting, the counterweight closes the draft regulator door. It is important to understand that no draft regulator can cause an increase in draft. It can only decrease draft over the fire. That is something that is so important when it comes to dealing with draft regulators, is understanding what it does. Okay, it's important to understand again that no draft regulator can cause an increase in draft. It can only decrease the draft over the fire. Okay, that's very, very important. It can also, cannot prevent downdrafts caused by wind currents blowing down the chimney. Obviously, that's just force of nature. Okay, the draft regulator should be installed in the flue pipe between the chimney and the stack-mounted primary control, if there is one. And again, if there is one, we're going to probably take that son of a bitch out because it's just no good and it's garbage. But it should be at least 10 inches to 12 inches from the control, and 18 inches is preferred. Again, if you have a stack-mounted primary control. If installed closer to the control, the cool air from the regulator can cause the unit to shut off on safety even when the system is operating properly. Okay, so if we look at this diagram here, this is kind of really important. This is the correct location for where we want our barometric dampers, okay? Here's our boiler. We want it no more than 10 inches or more away from the boiler, okay? Or not less than 18 inches away from wood joints or ceilings, okay? So that's where we kind of want to put them. Okay, some newer heating appliances are designed to operate without a draft regulator. Okay, the burner creates enough static pressure to move the combustion products up the chimney, and the heat exchangers are tight enough to resist the effects of strong and variable negative drafts. So as an oil heat appliance, always follow your manufacturer's instructions regarding draft and where to place your draft regulators. When it comes to measuring your chimney draft, we measure it in inches of water column. Okay, 1 inch of water column is the pressure difference required to lift a column of water 1 inch up a tube. Okay, typically chimney drafts required for oil-fired heating units are close to negative 0.05 inches of water column. Draft is checked in 2 places. The first place is going to be over the fire, okay, which is the draft at the top of the combustion area. And then the other place is going to be in the flue pipe, or better known as your breech. Before any measurements or adjustments are made, the condition of the draft regulator should be checked. Okay, obviously we have to make sure that it is there and in working condition. The pivot shaft should be horizontal and not crooked or cocked, and the door should swing freely. Okay, have the burner run long enough to make sure that the chimney is warm. And again, we're going to let a furnace run anywhere between 5 to 10 minutes before we start taking any sort of draft readings, because we want to make sure that things are warm. Okay, draft over the fire is the most important draft measurement and should always be measured first. The over the fire draft must be constant, so burner air delivery will also be constant. The setting must be high enough to ensure that combustion products do not leak into the building but are drawn through the heat exchanger. Normally, over the fire draft is going to be anywhere between negative 0.1 to negative 0.2. That is usually sufficient enough. If the over the fire draft is higher than the manufacturer's recommendations, again, typically negative 0.2, the draft regulator weight should be adjusted to allow the door to open more. If the draft is below the manufacturer's recommendations, the weight should be adjusted to close the regulator door. Some equipment can operate under very low to zero draft. Okay, in fact, some appliances operate under positive pressure, so that when the over-the-fire reading is taken, the draft is actually in a positive. If the draft regulator door is already wide open, you may need to install a larger or second regulator. Draft at the breech or in the flue pipe. After setting that over-the-fire draft, the draft at the breech should then be measured. This is your second reading. The draft in the flue pipe will be slightly higher than the fire over the draft due to the restrictions caused by your heat exchanger. Okay, this restriction, or their lack thereof, is a clue to the design and condition of the heat exchanger. A clean heat exchanger of good design will normally cause the breech draft to be in the range of anywhere between negative 0.3 and negative 0.7. when the over-the-fire draft is in the ranges of negative 0.1 to negative 0.2. The difference between the breech draft and the over-the-fire draft is often called the draft drop, or better known as pressure drop, across the heat exchanger. Okay, pressure drop across the heat exchanger. For example, if the breech draft is negative 0.07 and the over-the-fire draft is negative 0.2, you have a pressure drop of negative 0.05, okay, which is usually a good thing. Okay, excessive draft drop may indicate heavy soot and scale deposits inside the unit. It is also important to understand that over-the-fire draft is indirectly controlled. A burner operating at more than zero smoke will cause soot deposits to build in the heat exchanger. These deposits increase the draft drop, lowering the over-the-fire draft, reducing combustion air and creating more smoke. Sometimes there is little difference between the breech draft and the over the fire draft, usually with older units originally built for coal. If the boiler measures a low efficiency with a high stack temperature of 600 degrees or more, it may be possible to install baffles in the heat exchanger passages to kind of help remedy the problem. When it comes to chimney sizing, it is important to make sure that the chimney is sized correctly for safe and efficient operation of all the heating appliances that are connected to it. However, you have to make sure that you follow the manufacturer's instructions when you are installing these furnaces and installing them into a furnace to make sure that they're compatible. Okay, installing a flue pipe, be sure to check the condition of the flue pipe during each service call. If it looks questionable, simply replace it. Okay, the stack temperature on new high-efficiency units are much lower and are more likely to cause condensation and rust in the flue pipes. This is extremely important because combustion gases can enter the building if the flue pipe is porous or disconnected. Okay, the flue pipe must be at least 18 inches from a combustible wall or ceiling as a fire prevention measure. It should never be smaller than the flue pipe collar at the breech of the boiler or furnace. The flue pipe should be as short as possible and not exceed 10 feet of horizontal run unless a draft fan is being used. It should have a minimum of 1/4 inch per foot pitch from the appliance to the chimney and be run with minimum number of elbows. Okay, use 45-degree elbows instead of 90-degree elbows if possible. The flue pipe should be firmly joined with sheet metal screws and supported with straps or wire. It should be tightly fitted to the breeching and installed into a clay or metal thimble that is securely cemented into the chimney. No sort of dampers except for your barometric draft regulator should be installed in the flue pipe or your breeching. Okay, so problems with your chimney and draft. There's a lot of different things that can go wrong. Okay, you can have loose fitting clean out doors. You can have smoke pipe extending into the chimney. You can have loose seated pipes with the flue opening. You can have an offset. You can have a break in your chimney lining, okay, joists projecting into your chimney, an obstruction in the chimney, okay, maybe like a dead raccoon or something like that. You can have a chimney cap or a ventilator, or the top of the chimney is not high enough, okay. So there's a lot of different things that we need to look at when it comes to your fireplaces and your chimneys. Okay, lack of air in a furnace room. Okay, insulation, tight windows or doors, and tight construction can prevent outside air from entering the building. So when a building is so tight, the indoor air pressure drops below the outdoor air pressure and the appliance becomes back vented. Odors, soot, smoke, and carbon monoxide may be drawn into the building. Isolated combustion, which is basically taking some ductwork and ducting it from the outside and putting it directly into the burner, like you can see here in this picture, is the best solution to this sort of problem, and there are many effective isolated combustion air options that are available. When we are installing 2 or more pieces of equipment, for example, like a water heater and a furnace, into like a single chimney, we can do it in a couple of different ways. You can take the 2 flue pipes and they can be joined together with a Y connector. The exit or chimney side of the Y should be at least 1 size larger than the largest flue pipe. If you do not use the Y fitting, you can make a second opening in the chimney. So like you can kind of see here what this diagram is telling you. So here's our furnace, which is going to be connected based off of whatever size breech that is. Here's my barometric damper. It's going to get connected to a Y. Now we have our water heater that's also going to get connected to the Y. My size is actually just 1 size larger than both of these. So if this is a 6-inch flue pipe, both of these are 6 inches, this guy here is going to be at least like 7. If 2 or more openings are provided into one chimney flue, they must be at different levels. Like instead of using the Y option, you can do stuff like this. The flue pipe from the unit with the lower firing rate should enter at the highest level, consistent with available headroom and clearances for your combustible products. And a separate draft regulator should be installed with each of those appliances. Okay, chimneys may suffer variable draft due to changes in wind or air turbulence. A simple and inexpensive solution to this problem is by installing a cap or hood over the top of the chimney. Okay, and when we are looking at chimneys, we're going to want to take a look at a couple of things. Now, if you are a professional chimney inspector, you're going to be checking the chimney to make sure that it extends a minimum of 2 feet above the roof level and extends above the surrounding objects such as trees. You're going to check to make sure that it's sloped concrete chimney tops. You're going to make sure that it's silicone seal and acid-resistant glaze tile liners. You're going to make sure that it has a 1/2-inch air gap around the tile liner, allows flue to heat up and establish draft quickly. But you, as the oil heating technician and gurus that you are going to make sure that you are inspecting your brick and mortar, making sure it's not damaged. You're going to make sure that there's no signs of condensate. You're going to make sure that there's no white powder or mineral deposits inside it. You're going to check for staining, all that sorts of crap. You want to make sure that that it's all in relatively good condition. As a service heating technician, you're also going to make sure that the flue pipe is flush to the inside of your tile liners. You're going to make sure that you don't have any flue pipes temperatures any less than 350 degrees. You're going to make sure that the seal, flue pipe, and thimble, you're going to make sure that it's all nice and sealed. You're going to make sure that you have a 12-inch maximum drop leg, airtight seals and cleanouts. You're going to make sure that you don't have any loose mortar, pieces of vinyl tile, all that crap. Okay? And if you're looking on the outside of a house, you're going to want to make sure that all of your venting is in the correct location. If it's going to be installed outside, you want to make sure that it is a minimum of 4 feet away from any windows. Vent hood must be at least 4 feet below windows, though not recommended. It's going to have to be a minimum of 1 foot high off the floor, 3 feet from any corner. Okay. If it's from any vent hoods, must be at least 7 feet above public walkways. So if you're going to have any sort of sidewalks around the house, that flue pipe has to be, especially if it's a side penetration, has to be at least a minimum of 7 feet off the ground, 4 feet away from any windows, 1 foot above any window, which is obviously, again, not really recommended. Air intakes must be located on the same wall or within 20 inches of your vent hood, or on the same wall or above snow level when more than 20 inches from your vent hood. And if you are on the ground, recommended clearances, your exhaust products containing sulfur, which can affect mechanical equipment, metal objects, and vegetation, you need to have a minimum of 10 inches anywhere, or 10 feet, 10 feet and 20 feet ahead of it. So obviously if there's any sort of shrubbery or anything like that that's going around it, it all has to be pushed away.